Today's webinar will be on some fundamental topics associated with utilizing HPC, namely HPC help and security. My name, as Cindy mentioned, is Nicole Wolter, and I am a computation and data science researcher at the San Diego Supercomputer Center, and I am one of the co-PIs on the complex proposal. So today's webinar is part of the NSF-funded Complex program. Complex stands for Comprehensive Learning for End Users for to effectively utilize cyber infrastructure. And the Complex curriculum was developed to address the changing base of the changing user base of the cyber infrastructure folks. Over the years, as HPC systems have changed, so have the people who are using them. So initially, the HPC systems were primarily used by folks developing their own codes in fields like physics, chemistry, and astronomy. And while these sciences still really dominate the systems, not all the users are still developing their own codes, and the user base is changing. Now we have fields like history, political science, agriculture, and one that was pretty surprising to me when I checked this, veterinary sciences. But essentially, these new fields traditionally do not include a curriculum for computer science and specifically not code development. So the complex training model was designed to focus on these groups specifically for non-programmers. So today I'm going to focus on the best ways to get help and to manage the risks associated with working on a shared HPC resource. This table of contents is primarily included to be used when we transcribe this webinar, but for a really quick overview, we will start with discussing the resources available to support HPC users and how to choose the most appropriate resource. And then we're going to follow that with a discussion on the importance of data security and some quick tips on securing your research, your data, and your credentials. While these kind of seem like fundamental topics, all these topics were drawn from and address frequently submitted help tickets. So I come with an agenda today. I am an end user of the system, and I'm also part of the support staff here at SDSC. So I've experienced the efforts and the stresses that come with using the HPC resource from both sides. So in this first section, the goal is going to be to help users reduce their stress associated with running into issues on HPC systems by providing tips on reducing the time to find a resolution for a problem that most people will inevitably encounter while they're using HPC resources. In addition, we're going to try and help reduce the overhead when you are working with user support. So we're going to provide some strategies to expedite the process to resolve an issue. That will include taking advantage of all the available resources that include the help desk. Excuse me. So to achieve this, we're going to discuss what specific help options are available to users and when it is recommended to use them or not recommended to use them. And we're going to also discuss how to create an effective help desk ticket. So something that everyone should always keep in mind is that HPC systems are shared resources. So to kind of help illustrate this, I pulled some statistics from XDMod, and it helps just give you a bit of perspective of what like the HPC HTC landscape looks like with respect to users. For those of you not familiar, XDMod is a tool that is used to monitor system utilization in the Access ecosystem. Access is an NSF-funded program to help researchers and educators utilize the nation's advanced cyber infrastructure and its resources. The Access portfolio currently includes at least 34 resources. These resources include supercomputers, smaller specialized compute clusters that are designed for unique computing capabilities. They also provide storage and data options. So the numbers I'm presenting represent an average day of utilization across the board. And on this particular given day, there are 1,718 active users who represented 415 institutions and 73 fields of science. So I want to clarify what that number of active users represents. It's not only the users who access the system on a day or have access to the system on a day, because there's lots more people who theoretically could access it, and it doesn't include the users who logged into the system and did some work on the login nodes. This only represents users who did something on one of the 14 systems that was reporting back to XDMod. Things that could be reported are running jobs that completed in a day, or if people were moving data around and it changed the size of the data that was being stored. So these users were part of 629 unique projects. So that indicates that along with sharing the cyber infrastructure resources with everyone, there's also a majority of these users who are specifically sharing their compute and storage allocations. They're also sharing Unix groups. We're going to talk about the implications of that sharing a little bit later in the presentation. The last number I wanted to share with you is the number of staff that support HPC systems. Well, the number I'm presenting today is not an exact number for all different centers. It is representative. At SDSC, the Expanse system is supported by 10 full-time FTEs, or full-time employees, I'm sorry. That includes the system staff, the networking staff, the security team, the team that's doing education and outreach. It includes the people who pay the bills, and it includes the help desk. So from this slide, there's two important takeaways. First, it's a shared system. That means that individual choices on the system will affect other individuals with respect to both the system performance and the security. And the second takeaway is that the end users far outnumber the support staff. So in the previous slide, we discussed all the users who are sharing the resources. And on this slide, I want to comment on what all is being actually shared by them. So this list is not comprehensive, but users, when they log into the system, are sharing the login nodes, the scheduler, the compute nodes, the file systems, and the support staff in that sense. So again, this list is not comprehensive, but it illustrates the shared nature of the system and why the performance and security on an HP system will be so influenced by the actions of the end users. So taking into account that users outnumber the support staff, streamlining support is essential. So let's start by examining what steps we should take to track down a problem. User support tickets often come in that are very vague. So they can say something like, my job failed, can you help? I can't log in, I can't access my files. And obviously, based on the information that a help desk is given, they can't do much with that. So the help desk will start to iterate with the users to get more details. What system are you running on? Has this code run before? Do you have a job ID? And on and on. But this emailing back and forth is going to take time and ultimately increase the time to get a resolution. So we recommend taking some time in advance to understand the problem before you reach out to anyone else. The first thing to do is obviously identify the problem. Then to strengthen a ticket or any questions you may have to ask out, try to identify the nature of the issue. If there is a useful error message, that's great. A lot of times the error messages aren't that helpful, but you can Google them and maybe get some more information, but provide it anyhow because the help staff might have seen it before. Ultimately, the goal is to provide as much information as possible that's relevant to the issue. Finally, you should try and identify the cause, depending on if the issue is based or code dependent, or if it's system dependent, or if it's a user themselves dependent. It's going to help you identify which correct support option you should use. So what are the available help options out there? Well, the help desk is the obvious option. As mentioned before, the help desk is a limited resource. Therefore, we want to discuss what other resources are out there for you. The end users themselves is probably the most valuable resource to address and resolve an issue. You, as the end user, will have the most knowledge of the specific problem being encountered and the means to collect all the pertinent information related to that problem. Oop, I'm sorry. The project members and colleagues are going to be another great resource, as they'll be closer to the problem than any external options you might have. Project members or colleagues may be familiar with the software that's being used, the data that's being used, and the science that's being done. They could have also possibly run the same workflow as you in the past, and therefore might have encountered the same problems. And in some cases, it's always helpful just to have someone close by who can look over your shoulder and say, oh yeah, you spelled work wrong, for instance. The third option is the internet. As we know, the internet has a ton of knowledge and information out there. Specifically, resource providers, hardware vendors, and software developers spend a whole lot of time and energy to create really thorough documentation. Those folks also usually maintain active user groups, they provide blogs, they have community forums, and they have Git repositories. All these options can be really useful in providing help, insight, support, and feedback. However, the disclaimer, as always, is one should always keep in mind that everything on the internet shouldn't be trusted. So make sure you evaluate the source of knowledge before downloading, opening, executing, or trusting anything. However, at the end of the day, you may find that the help desk or user support team is still going to be your best option. So when is it appropriate and probably optimal to reach out to the help desk? There's going to be specific cases when the help desk is either a software developer or the resource provider should be taken advantage of. Well, the end user and their colleague will be the most knowledgeable about the specific research and workflow that they're doing. The software developer will be the most knowledgeable about their tools. So the software developer is going to be the most qualified to address any performance or bug reports or issues. Along the same thread, the help desk is going to be the most knowledgeable with respect to their computer, the software they have on there, and the storage resources they have. They're also going to be able to tell you how to best utilize those resources. So for instance, to identify which file system a user should use for a given application, the help desk is going to be the most appropriate resource. Along those same lines, if a group wants to scale up a program to run multi-node, an HPC or HTC expert is going to be much more appropriate for that. Well, so it's going to be HPC in this case, but it's going to be much more appropriate. If the code was developed in-house on a laptop by a domain scientist, obviously that domain scientist has the most knowledge about the science. However, if they were trying to scale up, there's a risk that, especially if they're not computer's not their primary focus, that when they scale up on their own, their limited knowledge about the system could result in bad coding practices, which could in turn cause the program to run out of memory, and it could crash the nodes. So by going to one of the experts, you can ensure that the code will be developed to efficiently use the resources and not crash the system. If you do need to reach out to the help desk, it's important to create an informative ticket to ensure a really quick turnaround. If you have the attention of the help staff, you're going to want to keep it. If an email needs to be sent back and forth, most likely the supporter is not going to have the luxury to wait there and wait for the response. They're going to transition on to the next task. And until you get back to the top of the queue, it might take some time. So making sure that you have an effective help ticket initially is going to be advantageous to you to getting your issue resolved quickly. So to create this help desk ticket, start with a clear description of the issue. Make sure you include that what resources is being used. It's important because at many centers there could be multiple resources and there's different staff who support them. So if the resource is clearly defined in the ticket, it's going to be routed directly to the appropriate support team. Also make sure you include user information, including username and allocation. And make sure there's any additional relevant information. If it's related to a job, make sure you include the job ID at a minimum. Having a job ID provides the support staff and you yourself the means to find a lot about the information about your job. You can find information about a job while it's running, while it's pending, and after it's been completed. So if you have a job ID, a user can collect information including, but not limited to, which nodes it was running on, when it started, when it ended, the resources that were requested, and the resources that the scheduler decided to allocate. With this job ID, the help desk or the user can use the scheduler tools to recapture all the runtime information. So before we dive into some specific scheduling tools for finding useful information about the running and completed job, we should take a look at schedules in general. So schedules are used to manage jobs on the system. That includes allocating the resources, monitoring the jobs, managing the queue for pending jobs, generally control of all jobs on the cluster. There's several job schedulers out there. Some of them include Maui, PBS, Grid Engine, and Slurm. And while the syntax is going to vary between the schedulers, the general concepts and utilization is going to be the same. Ultimately, schedulers manage the running, monitor, modifying, and controlling of jobs. So in my examples, I'm going to use Slurm because it's widely used at many of the HPC centers, and it's also used here at SDSC. So a scheduler can be configured to set controls to manage jobs for on both a level for the users and for the project. There's a lot of things that can be configured by the system staff. And again, I'm just going to give you a limited list here, but it allows them to set limits on the job sizes. It allows them to set a duration on the job, the ability to allocate compute nodes either exclusively or non-exclusively. It also allows them to create constraints, and it allows them to set priorities, again, based on user group or even the age of the job. On the flip side, the end user's main interaction with the scheduler will be evaluating what their job is doing, and with batch scripts, where they have the ability within the configurations that are going to be set by the system staff to request resources for their jobs. So batch scripts are generally stored in simple text files containing lines with commands that get executed in sequence. Batch scripts can be used for many tasks on the system, but today we're going to be talking about HPC batch jobs. And those are going to be used for resource provisioning and to run workflows or applications on compute nodes. So users also have the option to run interactively, but batches is more commonly used at this time. So the great thing about batch jobs is that they don't require supervision or interaction. So they can be used to run applications for long periods or run workflows that have dependencies and don't require that have dependencies, but don't require you to put any input in, or any input that can't be scripted. The batch script allows users to request resources, set up environments, load modules, and execute commands. Ultimately, the job script or batch script is a set of Linux commands that is paired with a set of resource requirements that can be passed to the Slurm job scheduler. The Slurm job scheduler will use it to reserve resources according to the parameters that are set, and then it's going to execute the commands that are included in the job script when the resources become available. So some of the important parameters that are set in a job script include the allocation to charge to, setting up the runtime environment, setting up the resources required, including the compute time, the memory, and any special requirements such as identifying dependencies or reserving license. It also allows users to designate the location of where they want their input and output files to go, and it allows them to send them emails at the beginning or end of a job. So let's use a use case to take a closer look at schedulers and develop a good help desk ticket. In this scenario, the user realizes that their job wasn't running. Namely, they submitted the job and there was no command line error message that came back to them. And when they checked in their output directory, there weren't any error out files. So they could use the scheduler tools to evaluate why the job's not running. By using the SQ command, the user can quickly see if the job is still in the queue and why it's pending. In this case, the reason is listed as rec node not available, unavailable nodes, and it has a list of the nodes. So what this indicates is that based on the requested resource, the scheduler cannot find a resource that is going to fit the requested requirements at that given time. So this could indicate that the nodes are temporarily not available, or that there's an issue with what was requested. If it's something with what was requested, you can identify the offending request by reviewing your batch script or by using the Slurm command scontrol or sacket to view the job configurations. In this particular case, the user forgot to add in the memory parameter requesting the amount of memory that they needed. So a little bit more about the SQ command. The SQ command details a variety of information on an active job. This can be done for either running or queue jobs. You can see the job ID, the partition to which they are submitted, the job name, the username, the state code, and how long it's been running. Obviously, for queue jobs, this number is going to be 0. It will also provide the number of nodes requested, and finally, a node list or a reason. If the job is in a pending state, the reason will be provided. If the job is running, this column is going to have the nodes which the scheduler has reserved for the job and theoretically is using. In the top examples, we have 3 reasons given. There's max mem per limit, which indicates the job is in violation of or is violating the limit on the maximum number of memory per CPU or per node. The reservation reason is indicating that the job is waiting for an advanced reservation to become available. And the QoS max CPU per user limit is indicating that the CPU request is exceeding the maximum number allowed for an individual user for the requested QoS. Finally, max jobs per account indicates that the maximum number of jobs an account on an account or project can have running has been exceeded, and that's based on the QoS. Depending on the reason, a user might need to cancel their job and fix it and resubmit it, or they can have the help desk modify it kind of on the fly. Or if it's just waiting for resources, you just simply can leave it in the queue and it will run as soon as it's eligible or the resources become available. So there's many queue states, but the most persistent queue state is going to be pending and running. There are also many more reasons for a job being in the pending state than we discussed in the previous slide. The reasons generally indicate that the requested resources are not available, the job has dependencies that are not being satisfied, the job is requesting a resource that does not exist, a user or group is beyond the set limits, or the job is being held for maintenance. So the system teams can set up site-specific constraints as well. So for an example, at SDSC at some point, we were having some intermittent Lustre file issues where Lustre was not available on some of the compute nodes. So instead of us holding all the jobs for all the users or just allowing the Lustre-dependent jobs to fail, the team added a Slurm constraint to help users self-identify if they needed to use Lustre. When the constraint was included in the batch script, the scheduler was aware that the job needed to use Lustre, and then it didn't schedule any of the jobs on nodes where Lustre was missing. So users were able to explicitly request these features by including an SBatch directive constraint. Another tool we can use to help view or modify our currently queued or running jobs is the scontrol command. The scontrol command will show all the information associated with a job, including location and the job script. The sacket command, on the other hand, provides accounting data for completed jobs. So as you can see from the list provided here, there's a broad range of information that can be reported for the job. But on the nice side, it can also be formatted to provide only the select information you're looking for. And in most cases, I'm going to recommend that you format this command, as the full listing can be really difficult to read because it wraps, and a lot of the parameters won't be informative to you or the issue that you're currently having. So if the SQ command returns a pending reason, it may indicate that your job has exceeded some system limit or is being held while it waits for resources. All providers set their own limits based on what resources are available and what their system's priorities are. So I would strongly encourage users to review the limits imposed by the providers by checking out the user guide, or they can also use scheduler commands to see what the current settings are on the system. In Slurm, the tool to use will be sacket manager command, and it will help to view the Slurm QoS information. In general, saccount manager command can be used to assist users to view and modify Slurm account information. If a job is not running against user or system set limits, the error may indicate that the system's busy. So to learn a little bit more about the current state of the partition, you can use the SQ command to see everyone who's running at a time. But you can also, to check on the partition and nodes, you can use the sinfo command. The sinfo command provides information about Slurm nodes and partitions, including their current availability, the time limits that you can use on it, and their current state. So let's take a look at another case scenario. A common concern for users is that they're burning through their allocations too quickly. Again, a great place to start for this is the user guide. All the systems will provide you with charging policies at a given center, since centers charge differently. Some resources are allocated in node hours, some are allocated in core hours, some in GPU hours, some are in core minutes nowadays. In addition, the definition of what a node hour means could be different between the different centers. So while a system is allocated in a core hour, it may additionally charge based on the memory or other available resource featured on the node. So another opportunity to ensure that you're not wasting resources is to check if the nodes are allocated exclusively or non-exclusively. It's important to note that generally jobs are going to be charged based on the resources that you're requesting and not exactly how you use them. If nodes are non-exclusive, which means you can share them with other users, you can limit what you request to just what you need and only be charged for what you need. So with respect to memory, it's very common for users to end up requesting far more memory or resources, or time for that matter, than their jobs really require. And this can end up being really costly on a personal basis. But again, if you're sharing your allocation with the group, you're also wasting the group's allocation. So by reserving more resources than needed, the compute resources will not be available for other users, and it's going to cost more. Requesting more resources than are needed may also reduce the number of jobs that a group can run. Remember, we mentioned the QoS, which sets limits based on groups. Centers set these limits to make sure that no one user or group can dominate the entire queue or resource. On the flip side, if you're too strict on the resource requirements, such as memory or time, especially if you're using the shared nodes, it could cause your job not to complete if it runs out of resources. So a general recommendation is to ask the scheduler for like 10 or 20% more time or memory than you expect the job to need. This makes sure that any minor fluctuations due to other people running on the node don't cause your job to be canceled by the scheduler. So to help evaluate the requirements of a job before starting a large workflow, it's generally recommended to do a couple test jobs before you do a large workflow. This is going to help you confirm that the scripts are actually good and you just don't waste a lot of SUs. And it also helps you figure out what closer to the amount of resources that you're actually going to need. So after running test jobs, a user can use the sacket commands to evaluate the impact of the job, and then use that knowledge to help better manage the resources and the allocations. To assist you in managing resources, along with the Slurm native tools, many centers provide other tools to evaluate project usage. Most of these are homegrown tools and will be unique to each resource. In the case of the Access program, jobs are accounted for both on the local systems, and then they're reported back up to the Access database. The Access portal will provide a centralized accounting data there. However, the accounting information on the resource itself is usually going to be more up to date and should be considered as the point of truth. Sometimes there's problems sending packets back and forth, and the central database is usually the frequency which it's updated may vary between the centers. In our case, it's only updated once a day. So in summary, it's recommended to check the user guides for accounting policies. You can use scheduler commands to help to assist in evaluating queued, running, or completed jobs, as well as scheduler policies and node states. So let's take another case scenario. A very common task of the users is common ask of the users to the help desk is to install specific software packages. Generally, on a high-performance computing system, your software is not going to be available to you right when you log in. However, HPC centers usually maintain comprehensive software stacks, and they make the software available via modules. Sometimes they can compile it on the system and have it in designated directories, or they can provide containers for you. It should be noted that users also have the option to compile, containerize, or create their own modules for their applications. But it's going to be generally recommended to use the center's installed software when available, as they will have tuned it specifically for their particular architecture. As a bit of an aside, if a user does choose to compile their own software, they should take note of the architecture of the resource of where they're compiling and where the job is going to run. In some cases, the login nodes and the compute nodes are different. So when compiling codes or running codes, make sure you have the proper modules loaded and you're on the proper nodes exactly. This thought about the different node types also applies when you're submitting batch jobs. So note that the environment set in the login node might not carry over to the compute nodes. And so any required modules should be loaded at runtime to ensure that you have a proper environment for your job. As mentioned, many of the HPC centers use module systems to manage software versioning and package conflicts. In general, a module is a self-contained description of a software package, and it's going to contain the settings required to run the software package and encode any required dependencies on other software packages. The module commands can set, change, or delete environment modules. The environment modules provide a convenient way to dynamically change a user's environment through module files. This includes easily adding or removing directories to the path environment variable. Module files for library packages provide environment variables that specify where a library and header files should be found. So there's 3 significant factors why centers use module files. Modules can help manage software incompatibilities, versioning, and dependencies. So software incompatibility is a big problem. The presence or the lack of presence of a software package will break others that depend on it. So for instance, software compiled against a newer version of a C library, if it's run where that library is not present, is going to run, it's going to result in a library not found error at the runtime. Software versioning is another common issue. HPC centers will often maintain multiple versions to support research groups depending on a certain package. So if a software version is to change, for instance, if the package is updated, it might affect the results of the project's research and also not allow them to reproduce results they've created in the past. So the ability to maintain multiple software versions allows the researchers to avoid software versioning issues from affecting the research. So here are some of the most commonly used module subcommands. To review what's currently loaded, users can use the module list command. Some systems will have default set of modules listed. Others may start with an empty environment. This is completely dependent on the setup of the system that you're using. Oops, sorry. Yeah, this is the right place. The next one was module avail, and this is going to list all the available software modules based on your current module path. So what modules you currently have loaded will dictate what you could load on top of it. Module spider will list all available software modules and all the versions that are on the system, regardless of what you currently have loaded. Module show module file will display additional information about currently loaded modules. You can load modules using the module load. You can unload them with the unload command. If you want to clear out everything, you can use the purge command. You can also do module reset, which will reset it to whatever the system defaults are. So in summary, regarding software, it's always recommended to review the user guide for the available tools and locations of available software. It's recommended to use the software installed by or software installed on the system already, as it's going to be tuned for the architecture. And in some cases, I didn't mention this too much, but if software is out of date, the containers are usually a good option. So to finish up with the getting help portion of the webinar, just a quick review. Always take time to understand your problem before reaching out for help. Make sure you engage with the appropriate tools and support. And when you're using the help desk, just a personal thing, always be nice to the help desk. So at this point, we're going to transition to the security portion of the webinar. And in this section, we're going to focus on the importance of data security and some of the tips to secure users' data, research, and credentials. But before we go on to some specific recommendations on how to protect ourselves, this is again a reminder that security is a shared responsibility between the system support team and all the users who have access to the resource. And that security is an ongoing project. Security and the security group and the systems group are constantly evaluating the system and applying updates and fixes to address and mitigate security concerns. And it's recommended that users do the same on their own personal systems. With that in mind, let's quickly discuss what users can expect from the resource providers in order to help keep their data safe. So the resource providers are going to be responsible to ensure that only authorized users have access to their resource. The flip side of that means that unauthorized users are not going to have access to the resource. In addition, and this is going to be a little nuanced one, they are going to ensure that authorized users to a resource do not have unauthorized access to other authorized users' data. And for this third one, they really need the help of the end users themselves. So to help ensure that the resource provider is able to maintain that third responsibility, the end user is going to need to protect their credentials. One should never, ever, ever share credentials. The end user is going to need to set up appropriate access permissions for their data, and the end user needs to only use the resource for what they have been authorized to use the resource for. As with help, I also have an agenda with the security talk. Users often see security as slightly frustrating, as they think it's going to interfere with their research, slow down their workflow, and to be honest, it is a little daunting. But the intent of this talk is to remind users of the risks and to provide some simple and easy tips. They might have a little bit of an overhead in the beginning, but it's going to help reduce the risk and then potentially even simplify things down the road. Ultimately, the goal of this talk is to encourage users to reflect on their current security practices and adjust where needed to best manage the risk to their projects and to others that they share the resources with. So many of us have been required by our respective universities or employers to undergo some sort of security training, but it usually focuses on data breaches. So the description of data breach that I'm bringing is any incident in which confidential or sensitive information has been accessed without permission, and that unauthorized access led to the loss of control of private, sensitive, confidential, personal, and/or financial data. So, big disclaimer here, in general, HPC systems are by default not set up to handle sensitive data or secure data. That's not to be said that there's not opportunities out there to use HPC centers for secure data, but the default, a user should make sure they contact their specific provider in advance to ensure the system meets their specific requirements and that the system's aware of what is on their system. In general, those users who handle sensitive data should pretty well be aware of the restrictions that are placed on their data sets and plan accordingly to contact the centers as needed. So our discussion today is not going to be on data breaches, but it will be on data security and focus on maintaining a secure research environment by safeguarding our digital information and protecting it from theft, unauthorized access, loss, or corruption. What we're protecting is going to be our hardware, our software, our storage devices, and any other devices that are used to access or communicate with the HPC resources. So why do we need data security? I tried to pull some useful statistics on the data loss while I was preparing this talk. And while all the sites agreed, they didn't agree on numbers, but it was generally agreed upon that all users at some point will lose some data. So we need to protect our data and resources to avoid loss and access to and corruption of data and other resources. Another way to put it is we want to maintain access to and ensure the integrity of our data, our research, and our resources. In general, by maintaining controlled access to our personal resources and data, we're not only protecting our personal data and resources, but also that of our collaborators and associates. I'll remind everyone again that security is a shared responsibility, not only between the resource provider and the end users, but between all the end users as well. So when do we need to protect ourselves? And the answer is always. It's important to remember that even if you think you don't have anything interesting to others, and you don't work with sensitive protective data, and you consider your research as public, it will be no less frustrating if at the end of the day, you lose access to your research and data. So while you may think you don't have anything of interest, attackers are opportunistic. Attackers may simply be playing around to test their skills. They could be looking for something specific that you hadn't considered might be interesting to them. They could also be interested in the system that you're working on or somebody else who's working on that system. The flip side to all of this is that the attack may not be deliberate. So while the theft and unauthorized access could be a direct deliberate attack, data loss and data corruption could occur for a lot of other reasons, completely unintentional. So we need to protect against those as well. So unintentional causes could include hard drive crashes. It could be caused by system or software failures, and of course, human error. So this leads us into this discussion of who we need to protect ourselves from. Well, we're obviously concerned with protecting ourselves from external folks who are out there to inflict deliberate and intentional harm, or just create some general mischief. We also need to protect ourselves from unforeseeable occurrences and unintentional and inadvertent actions from ourselves, our peers, and our systems. I mean, how many of us have inadvertently deleted a file or a document? And in the best case scenario, we only deleted our personal files. However, if you put in a typo there, it can exponentially escalate the situation. So let's look at a couple examples that have actually occurred on our system. The most tame one is kind of what I mentioned above. A user ran the remove-rf star command, and they were in the wrong directory. Unfortunately, a shared directory with their team. This indicates that they will have deleted all the files to which they had group write access to. A broader reaching mishap occurred when someone ran the command rm-rf/ and then there was a space, which shouldn't have been there, and then the directory structure. So that space is super important because essentially it says delete everything from the / directory. The / directory is the top of everyone's directory structure. So this recursively deleted or searched for and deleted all files that it could in the / directory. The last scenario is also kind of a daunting one. Namely, there was an instance where there was a hardware issue. And in some cases, it just caused some temporary loss of access to our files. In other cases, it corrupted some files. And in some other cases, it completely deleted the files. So now that we know who, when, and why we're protecting our data, let's discuss what exactly we need to protect. Ultimately, we're protecting our ability to access our resources that include our personal and shared devices, both the physical devices themselves and the software that we're running on it. We also need to protect our research, which includes our data and our source codes. And we want to protect our project on the whole to maintain the research integrity. So this includes us managing all the dependencies, making sure we have backups. The concept for complex was to focus on the non-programmers, which by definition means that probably some of you in this group are using somebody else's software. This is a big consideration. When you're using third-party software, users need to consider the source of the software and the stage it is that it's in its life cycle. You should check to see the last time the software was touched. Most software needs to be constantly patched to address security concerns. If a project has gone stale, chances are the developers are no longer keeping it up to date. Another consideration is if you're using somebody else's large software project. Large software projects often have lots of contributors and many even rely on third-party modules or libraries. So these projects are going to be dependent on all the contributed parties maintaining best practices to ensure that their software is behaving correctly and that the security is also up to date. If you're using third-party software, you are dependent on the diligence of others for the integrity of your research. So let's look at another common scenario that we get at the help desk. I can't log in. At this point, you're probably asking, well, why wasn't this in the help discussion of the talk? And while I can't log in, could be a simple issue that the account was not set up yet, or it's using an incorrect system name, or the credentials, or it's using incorrect name or credentials. The tickets still have cause for security concerns. We've received several times when a user will send the help desk not only their username, but their password in plain text to help us debug it. It's important that you never, ever, ever share your passwords. And everyone should know that a support desk is never going to need your personal credentials to assist you. So let's look at the help side of this scenario. If there is an issue with logging into a system, you should make sure you're using the correct username and the correct resource name. If that's not the issue, you should check the user guide or the system availability page, or you can also check for email notifications of potential system downtimes or login guidelines. However, if a ticket is still warranted, make sure you include your username and the specific system that you're trying to access and the status of your account, so if you've logged in before or not. Different centers have different methods for accessing their resources. Some use federated logins like CI login. Others use the standard username plus password, or they can use SSH keys. In addition, a lot of the centers are now adopting the requirement to have multi-factor authentication. In addition to having between centers having different things, centers themselves may have different access policies for different resources at the center, or based on how the resource is being accessed. For example, at SDSC, you can access Expanse either via our portal or via direct SSH login. If you're using direct SSH login, you're going to need to use your SDSC local username and a password that's either associated with Exceed or UCSD or an SSH key, depending on how your account is set up. However, if you're using the Expanse portal, you're always going to be using a CI logon, which is going to require a username and password of the selected organization that you clicked on. So again, for our portal, it's going to be either Exceed credentials or UCSD credentials, or there you can also use OrcID credentials. The thing to note is that the SDSC local username is very often different from, say, the Exceed username or your personal organizational name. So it's always good to review the user guide and find the appropriate access credentials and policies. But this brings us back to the security portion of authentication. And while authentication varies between the resources, in general, it's going to require some sort of password-based or passphrase-based authentication. So let's talk a little bit about what a good password is. Old wisdom tells us that a good password contains uppercase, lowercase, special characters, numbers, and it needs to be X amount of characters long, and that it should be changed on a regular basis. However, frequently changed gibberish as passwords can be really hard to remember and type. So what our security team recommends is that while you use less complexity, but you make them longer passwords. So sentences, my dog ran into a cat. And logically, if you think about this, for a hacker, it's much easier to guess 8 characters than it would be to guess like 24 plus or something. Also, if you use passphrases, it could be easier to remember than the gibberish of the random letters and numbers. Another recommendation that they provide is to use different passwords for different services to ensure that if a password is exposed at one place, it does not compromise another place or service. Another recommendation is not to keep digital plain text records of your passphrases on your system. If you do choose to maintain digital copies, you need to make sure that they're sufficiently encrypted. We recommend using a password manager. Because the password managers will encrypt them for you. You should take a moment to review what the password managers encrypt and what they don't. We found in some cases that while they encrypt passwords, they don't necessarily encrypt the keys that are associated with them. Another great reason for using a password manager, it's going to help you remember your username and passwords at the various sites. Sometimes password managers have a fee associated with them, so it's recommended that you check with your institution on what they might make available to you for free. You could also choose to be old-fashioned and just write it down on pen and paper. If you do choose to write it down with pen and paper, make sure that your written down stuff is physically secure. And the final tip that we'll provide here is don't hard code passwords or store private keys in plain text files. So one of the ways to access HPC systems is by using SSH, or Secure Socket Shell. Secure Socket Shell is a cryptographic protocol, and it's primarily used to enable secure access to remote servers and devices. It also allows for the secure execution of commands on remote systems, secure remote delivery of software updates, and secure interactive and automated file transfers. SSH supports a number of different authentication mechanisms, which include SSH keys. So for an added level of security to avoid using passwords, users can set up SSH keys. SSH keys are a pair of public and private keys that are used to authenticate and establish an encrypted communication channel between a local and a remote host. So setting up SSH keys is pretty straightforward. On a Linux system, to generate a key pair, you can use the command SSH keygen. And then you just need to copy your public key to a remote host. SSH supports several public key algorithms and different key sizes for authentication. They provide RSA, DSA, ED, ECDSA. It should be noted that RSA is the default right now, and also that DSA shouldn't be used really any longer. It's generally been replaced by the ECDSA. It's also really, really important to make sure that your private keys are only on a computer that you have physical control over. So, for example, you should never create or store private keys on a shared system such as the HPC systems that we have. It is, however, completely okay to use the same key pair everywhere. Again, assuming that your private key is private and protected. Another layer to minimize the risk and reduce the number of times a user needs to type their password is to use an SSH agent for agent forwarding. An SSH agent is a helper program that tracks the use of users' identity keys and their passphrases. The agent uses the stored keys to log into other servers without requiring a user to type in a password or a passphrase again. So this is an implementation of single sign-on. When using SSH agent to secure private keys, it will allow that the private keys do not need to live on disk in plain text, but it will still allow them to be accessible as if they were, and it allows a communication with the agent to be forwarded or proxied. So some things we need to keep in mind. Whenever your system is rebooted, the agent will expunge any keys that are in it. So each time it's rebooted, you're going to need to re-add them. It's also strongly recommended never to leave keys lying around. So if you're not using them, make sure you delete them and make sure you don't leave it on a system for a long period of time. The steps to use SSH agent are pretty straightforward again. Since we learned on the last slide how to create our SSH key pair, the next step would be to get an SSH agent and activate it on your local system. On Linux systems, the tool that you're going to use is SSH agent. On Windows, you can use Putty agent or Pageant. Then you're going to add your private key or verify that your private key is on. Then you're going to add your private key to the SSH agent and make sure that your public key is on the remote host. or added if necessary. So we have a link down at the bottom here that provides step-by-step instructions for how to create an SSH key pair and for setting up SSH forwarding. If you are using passwords, make sure you don't reuse passwords. Longer passwords are better. Don't keep plain text copies of passwords. And again, never share your credentials. Don't hard code passwords or store private keys in plain text files. If you're going to be using SSH keys, make sure you use a passphrase when creating the SSH keys. Make sure you keep your private keys private and on a computer that you have physical control over. And it's okay to use the key pair everywhere as long as you've kept it private. You can use PuTTyGen for creating a key pair on Windows and SSH keygen for creating it on a Mac or a Linux system. You can use SSH agent to secure private keys, and it's recommended that you always use multi-factor authentication if it's available. So we have another use case. My files have vanished. So a user, Sally, contacts the help desk that her files have vanished. And so we drive back a little bit, and it all started with a simple request by a PI. Please make the files accessible to all the following users. So an overeager, obliging grad student, I apologize to grad students here, but they're a good person to get here. We will call, so this obliging grad student, we're going to call him Sunny, quickly appeases the boss and modifies the file permissions to allow all the users to read, write, and execute in the file directory. And everyone's happy. Everyone can read the files. Everyone can modify the files, and everyone can execute the scripts. It's a perfect solution, right? Well, a few weeks later, Sally goes into the directory and finds that all her files are vanished. What happened? So there's lots of options. In trying to figure out what happened in this situation, there's some initial questions you should ask, like where was the data stored, who has access to the data, and when was the data last accessed? The first thing we're going to want to explore if files are missing are who had access to the files. On HPC systems, generally we have standard permissions set when new files or directories are created, but that doesn't say that users can't change them. So users are allowed to manage access to their data via the Unix access controls. Users control who has access to their data. It's critical that users properly set permissions on files to ensure that only authorized users have access to their data. With the permission controls, a user can control their personal, so the file ownership of the files. It can designate a specific group who can modify those files. And there's another group that is everyone else or world. It's strongly recommended to always start with the least amount of privileges and only add when necessary. Users can use the chmod or the chown commands to create appropriate group ownership and specific permissions on group to safeguard the data. So our grad student, Sunny, from our case scenario, what he chose to do, just for simplicity, since he didn't know that what everyone's group memberships were, was he just opened the directory to everyone, world, read, write, and execute. What Sunny should have done was identify a common group of users who needed access and only open the directory for read and execute. This would allow the users to copy the files out if needed, or to modify them, or to read the data, but not modify them in place. In addition, if they set a GID, any files in that directory would have inherited the group set at the top directory. To find out which groups a user is in, you can use the ID command or the groups command. If there are no common groups between all the users, centers are generally more than happy to create a new access group and/or create additional directories or that are completely independent of an individual user to accommodate the project to ensure security. Another cause of Sally's frustration and Sunny's mishap could have been associated with where the files were stored. It's very important that when users get onto a new system, they take a moment to review the user guide with respect to the file systems available and the recommendations on how to use those file systems. It's also very important to take note of the individual file systems retention policies. So if there's a purge on them, and their backup policies. This information should be in the user guide, and it will help the users make decisions on where to run their jobs, where to store their data, and help them devise a backup plan. Note that different resources will have different purge policies and backup policies on similarly named file systems. So generally, centers provide a few different locations to store your data. Most of them have something called home. They have some options for scratch. They'll have some persistent storage and potentially even archival storage. Another thing that we should note is that there are different types of file systems available, and the different file systems are designed with unique structure and logic, and they have different properties associated with them with respect to speed, flexibility, security, and size. And this will accommodate different workflows. So there's lots of different file systems out there used by the HPC systems, including NSF, GPFS, Ceph, and Lustre. So making sure you evaluate the different file systems for their strengths and weaknesses will again help users decide where to best run their codes, store their data, and dictate their backup plans. Sunny should have had a backup plan. So it's important to have a backup plan, and almost as important to test that plan to make sure that it works, that your backup plan and your recovery plan actually recovers everything you need for your data and research. When you consider a storage plan, review the retention and backup policies on the system on which you store your data. In some centers, or in some cases, centers may create snapshots in the case of a catastrophic failure or recovery, but that most likely isn't going to capture your thesis project that you updated yesterday. And even if HPC systems keep backups, it's generally, it might not cover all the file systems. It's generally there for disaster recovery, not really to recover an individual file or directory that was accidentally deleted. So what this all means is that ultimately the responsibility for protecting any critical data and corruption from deletion is really going to land on the end user. So backup plans could and should maybe include versioning, such as Git. Normally, these are used for storing source codes, but if you're not writing your own programs, they can also be really useful for storing job scripts, analysis scripts, and small input files. If you use a Git repository, one thing you should be very careful about is to maintain clean commits. So there was a case where a user's key was exposed in a Python notebook. So in the output window that echoes commands, it was placed in there. And then when the notebook was cloned and pushed back into the Git repository, that wasn't cleaned out. So the key was identified really quickly, and then the attacker started accessing resources with it. Unfortunately, this was actually an AWS thing, so they were actually spending real money, and it ended up being very costly. Another thing is when doing backups is to use checksum. A checksum is a technique used to determine the authenticity of received data. So to detect if there was an error or damage when the file was in transmission. Any backup is only going to be useful if it's complete and correct. Another comment that we strongly recommend is to convert many small files into like a single archive before you transfer it back and forth. Another consideration that HPC systems are generally time limited, and projects should plan ahead for transferring data back and forth. The time required to transfer large amounts of data shouldn't be underestimated. For larger amounts of data, projects should have really robust systems in place for taking copies of critical data off the HPC systems and putting on backed up storage. Some tools you can use are rsync or Globus can be really useful for this. If you do need to do large backups, I would recommend contacting a help desk, as they'll be able to provide you with some good guidance and the options for data transfer for the volumes of data that you'll be using. In summary, a solid backup plan may have saved the day for Sally and Sunny. So in summary, users and projects should plan to back up critical data, and how they should plan to back up critical data and how that's going to be transferred off the system throughout the project. Backup should be done on a regular interval. The frequency of backups will be dependent on the needs of the project. Things to consider are the rate that things change in the project. You should make sure that backups are made of good versions in order to cover all your bases. You might want to keep a few versions, so just in case you'll have at least one good version in case you make some changes and you didn't test it before you sent it back. It's always recommended when you're transferring data to use the checksum to make sure the backups are clean. Another comment is don't back up everything. Smaller backups are going to be easier to manage and create and ensure the integrity on. Things that you should back up are like source code, output files, and scripts. Things you should definitely not back up are large data sets that you can very easily download from the web. Another thing to keep in mind is that backups are not local to the resource on which the original data is stored, and make sure that access to the remote backup is not tied to the original source either. Also, it's really important that once you have your backup plan, try restoring the process, and make sure you have everything you need. So as we start to wrap things up, sorry, I'm going a little over time. The best practices for risk management is to manage your credentials, manage your files and directories, and ensure you have a data resiliency plan. Make sure you protect your personal devices, and this is going to help you protect our shared devices. Best practices for project security: make sure you reduce dependencies on third-party software and libraries. Protect web-based applications on shared resources such as Jupyter Notebooks and Globus Connect Personal. SDSC on ourselves, we really discourage user-run network services and we provide a secure means for setting up Jupyter Notebooks and Globus endpoints for folks to use. If you really need to run your own services, make sure you contact the help desk of the center so that they can assist you. In conclusion, you should always manage your risk by securing your accounts, research, and data. Make sure you're a good citizen. And there's help available out there if you know where to look. Just a reminder that this is not a totally comprehensive presentation, but it was intended to raise the awareness of available tools and techniques to help you get help and to create a more secure environment. We pointed out some pitfalls that may occur and some tools and techniques to help avoid them. And here are some links to some additional resources and a couple of full-length security lectures by our security team, and also that are available in our training catalog. So I thank you for your time. I apologize I ran over. And are there any questions?